Good morning everyone. So let us start our class. So we were discussing integrals and today is the second video regarding it. In the previous video we have discussed what was integrals. So what was integrals? Integral means how something is gathering or accumulating, that was integrals, right? And then we came to know that it is nothing basically but area under a closed figure. And then we have seen that it is very easy to find the area under a closed figure if it is made up of straight lines, because in case of straight lines, if you are calculating area which is covered by straight lines, then one variable is always constant. So the problem starts when we try to find the area under like this curve, because in real life always say your speed will not be constant or whatever, means in reality we have to find the area under closed curve. And to find the area under closed curve, this was the main problem. It is difficult to find area under closed curve. So today we are going to discuss how mathematicians finally find out a way, you can say trick or jugaad, to find the area under the closed curve. In the third part of the video, we will basically see the shortcut given by Newton and Leibniz. Okay, so today we are not going to discuss about the shortcut. That shortcut we'll discuss in the third video, which today we know as integrals. Today we are going to see a different thing. Means before before Newton and Leibniz also, mathematicians found out a way to find area under closed curve. Today we are going to see that way. Okay, how they used to find out the area under the closed curve. So to find the area under this shape, what they were to do, they used to divide this curve in say small rectangles or square. For example, say let us divide this curve into two rectangles. Okay, this is first rectangle, this is second rectangle. Now we need to find the area under this curve. So to find the area under this curve, that is this shape, what will be the total area? Total area will be area of rectangle 1 plus area of rectangle 2 plus this shaded area, because this is not a rectangle, right? So if we find the area of this rectangle, then this rectangle, and if we calculate this shaded area, we will get the total area under the curve. This was the first idea. Okay, so how to find the area of this rectangle? Area of the rectangle is what? Length into breadth. Easy to find, right? We know it is easy to find area under straight lines. Okay, so what will be the breadth? See, the breadth of the rectangle we will decide. Okay, because we have made the rectangle, so we will decide what is the breadth of the rectangle. It is in our hand. So say breadth of the rectangle is delta x. Why we have used delta x? Because delta means small. Okay, small. It is not that big. The breadth of the rectangle is small. So breadth of the rectangle is delta x. But what will be the length of the rectangle? This is very important. What will be the length of the rectangle? In the previous video, I have said one line that it is very important, and that is what? Y must be a function of x. They must be related. X and y must be related. If they are not related, if there is no relation between x and y, you cannot find derivative, you cannot find integral. See, for example, say at x1, if I don't know, so this is my length, right? Length into breadth. So this is the breadth. The breadth of the rectangle is delta x. This is delta x. I know that value. But this is length. Now what will be length? Without knowing the function, how can you find out what is the length? If you know the function, say for example, say x square is the function. So if the value of x1 is 3, so then the value of y will be what? It will be 3 square 9. So your length will be 9. If the value is 4, then this will be 4 square what? 16. That's why y must be a function of x. You must know the function. In the lower class also, I say in class 7 and 8 in the chapter linear equation, you have seen that in the question you will see that the length of the rectangle is 3 times the breadth. The length of the rectangle is 5 more than 2 times the breadth. So what is this thing? 5 more than 2 times the breadth. 5 plus twice x. This is nothing but the function. The length and breadth, or you can say x and y, they must be related. They must be function of each other. Otherwise you cannot find. Okay. So how to find the length? They must be a function. So the function is fx. So at x1, what will be the value of the function? At x1, the value of the function will be what? F of x1. Say for example, the function is x square. So this will be y is equal to x square then. Okay. Put the value of x, you will get the result. You will put the input, you will get the output. Right? What is the value of the length? Means what is the length at x2? Means what is the value of the function at x2? At x2, value of the function will be what? F of x2. right? So this is the length. So to find the length, you must know the function. So what will be the total area? What area of the first rectangle? What is the area of the first rectangle? It is length into breadth. Breadth is delta x, and what is length? That is the value of the function at x1. At x1, the value of the function is what? F of x1. So the length of the rectangle is what? F of x1. So area of the rectangle will be length into breadth, f of x1 into delta x, plus what is the area of the rectangle 2? That is f of length of the rectangle will be x2, f of x2 into breadth is what? Delta x. So this is area of the first rectangle plus area of the second rectangle plus shaded area. So you see, it was looking impossible to find how to find this area under the curve, but suddenly with the help of rectangles, as soon as we have broken down the area into rectangles, suddenly we are able to find the area. Not exactly, because still there is shaded area, but something we have solved. Few area we have found out. See, this much area we were able to find, which was not easy to find earlier. By using the concept of rectangles, now this much area we are able to find. Only this much area is the problem, the shaded area part. So now what is our second objective? Our now main objective is what? Our main objective is to reduce this shaded area as much as we can. To reduce this shaded area as much as we can and to increase this area of the rectangle. Means this should be more and this should be less. So what is the trick to do that? So the trick was, you make more rectangles. The more there will be the number of rectangles, the less will be the shaded area. Try take a pen and paper and you try to make, now I make 2 rectangles, you make 4 rectangles or 5 rectangles, and you see the shaded area will be less. So this is the trick. The more you increase the number of rectangles, see, the more you will increase the number of rectangles, the breadth will be what? The breadth of the rectangle will be small. In short, if I reduce delta x, the breadth of the rectangle, if I reduce, obviously the more rectangle will come. So to make more rectangles, the main objective we have to do, we have to reduce the value of delta x. Means we have to reduce the breadth of the rectangle. Clear? So say now imagine, obviously imagine to be n rectangles. Now I cannot draw here n rectangles. Okay, hardly I have made, I think so, 14-15 rectangles over here. Okay, but we can imagine, right? 4 rectangles, 5 rectangles, so we can draw. Imagine there to be n number of rectangles. If we draw, say there is n number of rectangles. Okay, say there is n number of rectangles. So you see, this is the shaded area part. Okay, these all are rectangles. Rectangle number 1, rectangle number 2, rectangle number 3. So you see the shaded area has become so less, almost negligible. There is only 15 or 16 rectangles. If there is, you imagine to be n rectangles, 100, 200, 1 lakh, 2 lakh, n rectangles, the shaded area will be almost negligible. This part I was not able to shade because with marker pen it is not easy to draw. Okay, so you can just imagine what would happen if there would have stayed n rectangle. So then the total area will be approximately equal to, not exactly equal to, approximately equal to summation f of xi into delta x, and the value of I is 1 to n. Where is the shaded area? The shaded area is negligible. That's why I have said approximately equal to, not exactly equal to, because there is still some negligible amount of shaded area left, right? Summation, why summation? Because obviously you have to add the rectangles, right? Rectangle number 1, rectangle number 2. So in this case what will happen? Rectangle 1, 2, 3, 4 till n we have to add. So summation means what? Summation means sum. So we will sum all the rectangles. It will be at first f of x1, then f of x2, then f of x3, put the value of 1, f of x1, then I is equal to 2, f of x2. So basically this will be the area of the rectangle, but this is approximately equal. Why approximately equal? Again, because there is still some shaded area left. So we have considered n number of rectangles and we have almost approximately got the area under this curve. You see, it is not exactly this, but almost approximately it is correct. Means by considering the help of rectangles, we are able to find the area of this rectangle. Sorry, area of this curve. Now, in case of n rectangles, you have seen. Now imagine there to be infinite number of rectangles, more than n, infinite. Use the concept of infinity. Okay, that is, if you have to make here infinite number of rectangles, then this delta x must be so small that it is almost 0 but not 0. This line I think we have already heard in class 11 in the chapter of limits, that it is almost 0 but not 0. Okay, that is delta x is approximately equal to 0. It is almost 0. It is so small because we are considering the infinity. Okay, we can imagine, right? It looks impossible, but we can imagine this thing. So our breadth of the rectangle is almost 0, means there is no gap, slightly negligible amount of gap, 0, almost 0. So then there will be no shaded area. There will be no shaded area. If we have considered n rectangle, there was negligible amount of shaded area. Now if we consider infinite number of rectangles, this shaded area will now not stay, because delta x is almost 0. There is no more gap, but not exactly 0. So what will be the total area then? Then the total area will be equal to, you have to bring the concept of limit here. Limit delta x is almost 0. That is, delta x tends to 0. It's approaching to 0, but it is not exactly 0. It's very, very close to 0. That's why we use delta. Okay. So delta x is approaching to 0. Summation I is equal to 1 to n f of x and delta x. Now I can use here equal to. Why? Because delta x is almost 0. The width of the rectangle is so small that it's almost 0 but not 0. So finally, using the concept of infinity, using the concept of limit, finally we were able to find the area under this curve. You've seen? See, the shaded area is going to be the more you increase the number of rectangles, the shaded area will be less, less and less. So with 2 rectangles, the shaded area was only this much. From this much, it became this much. 10 rectangles, shaded area more or less. N number of rectangles, shaded area is negligible. Infinite number of rectangles, then there will be no shaded area. So finally, using this concept, mathematician, finally they were able to find area under closed curve. Okay. So see, problem solve, but not exactly. Why? Why? Because this solution, whatever you have understood here, that how mathematician finally got this jugaad to find this area under the curve, it is good to listen. It is good to look at the paper. It is looking good in the board. It will look good on the paper. It is good to listen. It is good to discuss. It is good to imagine. But to find this area, this infinite area, to add so many rectangles, not 1 rectangle, 2 rectangles, infinite number of rectangles, practically it is not easy. Practically it is very, very difficult. You have understood? Practically this is very, very difficult. It looks good on the board. It looks good on the paper. It is good to hear. But practically if you try to find area in this way, it is very, very difficult. So there is a way. Mathematician found out a way. Before Newton and Leibniz will finally give the shortcut that we will discuss in the third video. But before that also, mathematician had a way. They had a jugaad, they had a trick to find the area, but the trick was difficult practically. Logically it was easy. Yes, delta x very small, almost 0 but not 0. You add infinite number of rectangles, the shaded area will be negligible, the shaded area will be totally gone. We can find the area of the curve. But practically if you go on to find area by adding all those rectangles, infinite number of rectangles, it is very, very difficult. Okay, so this is the problem with this method. They had the method, they had the way to find the area, but that way is not so easy to find. Okay, so finally in the next video, luckily Newton and Leibniz, they found out a shortcut, and that shortcut in today's world we known as integrals. That shortcut is known as integral. In the last part of this video, we will see what is the shortcut, and using that shortcut, this problem which is looking close to impossible, how to find this area, by using that shortcut, this thing will be solved in seconds. That shortcut is so simple that this problem will get the answer in second, and that shortcut we'll see in the third part of the video. Okay, you first check the first part of the video, what is integral, what was the problem, what were the challenges. Then today in this video we discussed how mathematician, they also had a way. What is this way? Today we have discussed, that is make infinite rectangles. So then the curve part will be almost negligible, it is gone, and we will finally get the area under the rectangle, under the curve. But the problem is, it is practically very, very difficult. So to today, this will discuss in this video. In the next video, we'll discuss the shortcut. Okay, if you have any doubt you can ask. Thank you.